Myself, Rajendra Karale. My qualification is MSc Chemistry there and experience is of 28 years. Now, today we are going to discuss about mole fraction, which is denoted by small x. Mole fraction is nothing but the ratio of number of moles of one component and total number of moles of all components present in the solution. Now it is represented by small x it is independent of temperature and unitless. It is unitless. This is because it is the ratio of moles. Now here write down mole fraction equal to number of moles of one component divided by total number of moles of all components. That means here, how will you recall this? The definition of mole fraction. Mole fraction. Fraction means ratio which is less than 1. How it is possible? Consider the number of moles of one component in the numerator and total number of moles of all components in the denominator. Now let us write down the expression for mole fraction. Here let the binary solution contain the two components, that is solvent capital A and solute capital B. Now keep in mind here the most important point is that in this unit solvent is represented by capital A and solute is represented by capital B. Now here XA and XB are the mole fraction of solvent A and solute B respectively. Second, Na and Nb are the number of moles of solvent A and solute B respectively. Here total number of moles of solvent A and solute B equal to Na plus Nb. Now here write down mole fraction equal to number of moles of one component upon total number of moles of all components. Equation number 1. Now here the mole fraction of solvent A is here mole fraction of solvent A equal to number of moles of solvent A upon number of moles of solvent A plus number of moles of solute B. Now we are substitute the symbol, that is XA equal to Na upon Na plus Nb. This is your equation number 2. Then next mole fraction of solute B is, that means here mole fraction of solute B equal to number of moles of solute B upon number of moles of solvent A plus number of moles of solute B. Again substitute the symbol here. XB equal to NB upon Na plus NB, and this is your equation number 3. Now here where Na equal to Ma upon capital Ma and Nb equal to Mb upon capital MB, where Ma and Mb are the masses of solvent A and solute B respectively, and Ma and Mb are the molecular masses of solvent A and solute B respectively. Now here write down, prove that XA plus XB equal to 1. What is the meaning of this? Suppose binary solution contain two components, that is solvent A and solute B, then sum of mole fraction of all components present in the solution is equal to 1. Now let the binary solution contains the two components that is solvent A and solute B. Now here XA and XB are the mole fraction of solvent A and solute B respectively. Na and Nb are the number of moles of solvent A and solute B respectively. Now here total number of moles of solvent A and solute B equal to Na plus Nb. Now here mole fraction equal to number of moles of one component upon total number of moles of all components. Equation number 1. Now here the mole fraction of solvent A is here mole fraction of solvent A equal to number of moles of solvent A upon number of moles of solvent A plus number of moles of solute B. That means here xa equal to Na upon Na plus Nb, and this is your equation number 2. Now here the mole fraction of solute B is mole fraction of solute B equal to number of moles of solute B upon number of moles of solvent A plus number of moles of solute B. That means here XB equal to NB upon Na plus Nb, and this is your equation number 3. Now here adding equation 2 and equation 3, we get here XA plus XB equal to Na upon Na plus Nb plus Nb upon Na plus Nb. That means here XA plus XB equal to Na plus Nb upon Na plus Nb, that means XA plus XB equal to 1, where Na equal to Ma upon capital Ma and Nb equal to small mb upon capital MB. That means here Ma and MB are the masses of solvent A and solute B respectively, and capital Ma and MB are the molecular masses of solvent A and solute B respectively. That means here the mole fraction of the other component can be calculated if the mole fraction of one component of a binary solution is known. Suppose that means this is regarding about mole fraction, their definition, expression and proof, that is XA plus XB equal to 1. Suppose the solution contains three components like A, B and C. Then mole fraction of each component, that is XA equal to Na upon Na plus Nb plus Nc, Xb equal to Nb upon Na plus Nb plus Nc, and Xc equal to Nc upon Na plus Nb plus Nc. In this way you can calculate the mole fraction, and remaining part of this unit will be discussed in the next lecture.